Guys, let's try this problem right here. Here we have a Bernoulli differential equation and we are going to solve it. The first step in this one is going to be we have to check whether this is in standard form. And standard form of the Bernoulli differential equation should look like this: dy over dx plus p of xy is equal to f of xy power n. And here we have xy prime. Here we have dy over dx. Y prime is basically dy over dx, but we have an x right in front of this one, right? So we don't have this one right here. So what we have to do is we have to eliminate that one. To eliminate that one, what we do is we divide all of them by x, and that's going to give us y prime plus y over x is equal to 1 over x, and 1 over y square can be written as y power minus 2, right? So this is what we have, and this is now in standard form. After that, what we do is in Bernoulli's differential equation, we try to convert this one into first order linear differential equation pattern. To do that, we use this equation. We pick up a v value and equate that one to y power 1 minus n. So here the n value is going to be this one, whatever the value we have here. So this is our n value. So n is equal to -2, and if you substitute this one right here, this is going to become y power 1 minus -2, and we get y cube. So v is equal to y cube. Therefore y is equal to cube root of v, and this can be written as v power 1 over 3. Now we can replace all the y values with v power 1 over 3, but we have to do something about this y prime. So to do that, we have to find the derivative of this one. And here we are finding the derivative of this one with respect to y and x, so we have to use a chain rule. And if we find the derivative of this one, this is going to be 1 over 3 v power 1 over 3 minus 1, and that's going to give us -2 over 3. And then since it is a chain rule, we are going to have dv by dx, right? So we are going to have dv by dx after that, and this is going to be our y prime. Now we can go ahead and write our new equation in terms of v, and that's going to look like this. So now instead of y prime, we replace this one. This is going to be 1 over 3 is equal to, not equal to, actually 1 over 3 times v power -2 over 3 dv by dx, plus instead of y, we replace this v power 1 over 3. So this is going to be v power 1 over 3 over x is equal to, again for this one, we replace this one with -2 over 3. So -2 over 3 times, not -2, actually instead of y, we replace this v power 1 over 3 times this -2, that's going to make this one v power -2 over 3 over x. And the next step is we have to try to convert this one into linear first order differential equation pattern. Now in order to do this one in linear first order differential equation pattern, if you look at this one, the standard form should look like this: dy over dx plus p of xy f of x. And if you notice, we have dv by dx. Here we treat this v as y, so this is correct, but this value shouldn't be here. So to eliminate this one, we divide everything by this one: v power -2 over 3, v power -2 over 3, and this one also v power -2 over 3. And if we eliminate this one, this is going to become 1 over 3 dv by dx is equal to, and if I bring this one to the top, that's going to be just v. So we are going to have v over x, and in the other side of the equation, we are going to have just 1 over x. So this is our new equation. And if you look at the standard form, we don't have any constant in front, so we have to eliminate this 1 over 3 too, right? So to eliminate this one, what we do is we multiply everything by 3. So if we multiply everything by 3, this is going to become dv by dx plus 3v over x, and in the other side of the equation we are going to have 3 over x, and this is what we have right now. And the next step is we have this one, and we found out. So now what we have to do is we have to find out the integrating factor. To find the integrating factor, we have to use this formula: mu of x is equal to e power integration of p of x dx. P of x is basically this one. So after we have this dv by dx, whatever the value combined with this one with x. So let's write this one in better way. 3v over x can be written as 3 over x times v. So here we treat this v as y, right? So p of x is whatever the value in front of this one. So here we are going to have 3 over x. That's our p of x value. P of x is equal to 3 over x. And now we have to find the integrating factor. Mu of x is equal to e power integration of p of x dx. Now instead of p of x we place this one. So this is going to be e power. Since 3 is a constant, we can move it to the front. So this is going to be 3 integration 1 over x dx. And if we integrate 1 over x, that's going to become ln x. So this is going to be e power 3 ln x. And to get rid of this e and ln, what we can do is we can move the 3 to this side. So this is going to become e power ln x cube, right? So this is going to become e power ln x cube. Now we can cancel this e and ln. Finally, we will end up with x cube. So we have the integrating factor. Now what we have to do is we have to multiply both of these side by integrating factor. So we are going to multiply this side by x cube and also this side by x cube. So when we multiply this one, we should get, so let's get rid of these things. Right, so we need only this one later. We need v is equal to y cube later. V is equal to y cube. Let's note this one down and also erase this one, right? And now we have this one. When we multiply x cube by this, we are going to have dv by dx x cube plus, so here we are going to have 3 x cube divided by x. That's going to become 3x square v. And in the other side of the equation we are going to have, so this one should be multiplied by x cube, not cube, because x cube our integrating variable, actually integrating factor. So we have to multiply both sides by x cube, and if we multiply this side by x cube, this is going to become 3x square. And here the one thing is, if you separate this one like d over dx and vx cube, and if you find the derivative of this one, you will get the whole thing back. So if this is equal to this one, this must be equal to this one, 3x square. So now we have this one. The next thing is we have to integrate both sides respect to x. So integration with respect to x, and if we integrate this one, integration and derivative cancel each other. So we are going to left with vx cube, and in the other side of the equation we are going to have 3x cube divided by 3. So 3 cancels. We are going to have vx cube is equal to, also we have to put a constant right here, and vx cube is equal to x cube plus constant, and we have to bring this x cube to the other side. We are going to have v is equal to 1 plus c times x power minus 3. And we are not done yet, because this is in terms of v. Our original function was in terms of y, right? So we have to bring this value back. So what we do is we replace this v with y cube, and the general solution for this differential equation is going to be y cube is equal to 1 plus c x power minus 3. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.